Welcome back to Classified Dreams. Tonight, we're talking about something that arrived without warning, something that traveled for billions of years through the darkness between stars, something that, right now, is moving through our solar system. On July 1st, 2025, a telescope in Chile detected an object, fast, massive, coming from the direction where, in 1977, we received a signal we still can't explain. They called it 3I Atlas, the third visitor from beyond our solar system. NASA says it's a comet. A Harvard astrophysicist says it might be a spaceship. And when it passed Mars in October, just as the government shut down, the cameras watching it went silent. No images released, no data shared, just statements saying, "Nothing to see here." But the numbers don't lie. The trajectory is too perfect, the timing too convenient. And in late November, when it emerges from behind the sun, we'll either have answers or we'll have new questions. Tonight, we're walking through 100 facts, what they tell us, what they're hiding, and what might be watching us back. If you enjoy exploring these mysteries with us, feel free to subscribe. It helps others find their way here too, one sleepy soul at a time. And down in the comments, let us know, where in the world are you listening from tonight? Let's begin. Fact 1. On July 1st, 2025, the Atlas telescope in Rio Hurtado, Chile, detected an object moving through space faster than any known comet. The computer systems flagged it automatically, something moving at unusual speed, something that didn't fit the profile of the near-Earth asteroids Atlas was designed to track. Within hours, astronomers were pulling up the data, running calculations, checking and rechecking the numbers. The object was fast, impossibly fast for something bound to our sun's gravity. And the trajectory, when they traced it backward, didn't loop around the sun in a normal ellipse. It came from somewhere else, from between the stars, from interstellar space. Fact 2. The asteroid terrestrial impact last alert system wasn't looking for it. The system is designed to find rocks that might threaten Earth. That's the thing about discoveries like this. They're almost always accidental. Atlas watches the near-Earth environment, the space close to home where asteroids drift in predictable patterns. It's a warning system, a way to spot trouble before it arrives. But this object wasn't local. It wasn't part of our solar system's architecture. It was just passing through, and Atlas happened to catch it in the frame. A visitor from the void. The question was, how long had it been traveling? Fact 3. This object was coming from interstellar space, between the stars, from a journey that may have lasted billions of years. Think about that for a moment. Billions of years. Longer than complex life has existed on Earth. Longer than the dinosaurs, longer than the oceans, longer perhaps than our sun itself. This object had been drifting through the galaxy since before our planet formed, moving through the empty dark, untouched by any star's warmth. And now it was here, cutting through our neighborhood, close enough to photograph. The discovery went out through the Minor Planet Center, the clearinghouse for new astronomical findings. Word spread fast. Observatories around the world started pointing their instruments at the coordinates. But even as the excitement built, a question lingered. If the object was this bright, this large, why hadn't anyone seen it before July 1st? Fact 4. Within hours, astronomers started digging through old images, something called precovery, looking for earlier sightings they'd missed. Precovery is a standard practice. When you find something new, you go back through archived images, looking for the object in older data. It's a way to extend the observation window, to see where the object was weeks or months before the official discovery. And sure enough, they found it. Images from the Zwicky Transient Facility in California. Images from other Atlas telescopes around the world. The object had been visible, moving across the sky, recorded by automated systems that didn't know what they were looking at. Fact 5. They found observations going back to June 14th, 2025, meaning the object had been visible for over 2 weeks before anyone noticed. 2 weeks. It was right there, moving through the field of view, captured by survey telescopes designed to catch exactly this kind of thing, but it blended in. It didn't stand out until someone knew where to look, and when they dug even deeper, they found something more unsettling. Fact 6. Even more troubling, NASA's test satellite had captured images of it as far back as May 7, 2025, 2 months before the official discovery. NASA's Transiting Exoplanet Survey Satellite, TESS, scans huge swaths of sky looking for planets around distant stars. It's not looking for objects in our solar system, but it sees them anyway, moving through the frame as it stares at distant suns. And there, in the TESS data from early May, was 3I Atlas, already bright, already active, already visible. 2 months before the official discovery. 2 months when it was out there, and no one was paying attention. So the question becomes, why did it take so long to spot something so large, so bright, moving through space, where we were already looking? Fact 7. 3. I Atlas was arriving from the direction of Sagittarius, the constellation that points toward the center of our galaxy. Sagittarius, the Archer, the constellation that, from our perspective on Earth, marks the direction of the galactic core. The center of the Milky Way, where stars crowd together in vast numbers, where the light is brightest and the sky is most crowded. It's one of the densest, most active regions visible from Earth. A place where objects can hide in plain sight, lost in the glare and the noise of a billion distant suns. Fact 8. The galactic center is one of the brightest, most crowded regions of the sky, a perfect place to hide something until the last moment. If you wanted to approach a solar system without being detected early, you'd come from a direction where detection was hardest. You'd use the background light, the clutter, the sheer overwhelming brightness of the galactic core to mask your approach. And whether by accident or by design, 3I Atlas did exactly that. It came from Sagittarius, from the direction where our telescopes struggle to pick out faint, moving objects against the blazing backdrop. It stayed hidden until it was close, until it was too late to do anything but watch. On July 2, 2025, the Minor Planet Center made it official. Fact 9. The Minor Planet Center gave it the designation 3I on July 2, 2025, I for interstellar. 3, because it was only the third confirmed visitor from beyond our solar system. The naming convention is simple. 1I/Oumuamua, discovered in October 2017. 2I/Borisov, discovered in August 2019. And now 3I Atlas. 3 visitors in 8 years. Before 2017, we'd never confirmed an interstellar object at all. For all of human history, the sky was just ours. Planets, asteroids, comets, all born in our solar system, all bound to our Sunday. And then, suddenly, we started seeing travelers, objects from other stars, passing through. Fact 10. The first was Oumuamua in 2017. The second was 2I/Borisov in 2019. And now this 3 visitors, in 8 years after billions of years of nothing. Some astronomers said it made sense. Our detection technology had improved. Survey telescopes like Atlas and Pan-STARRS were watching more sky, more often, catching objects we would have missed a decade ago. We weren't seeing more visitors, we were just finally able to see them. But others wondered, 3 in 8 years, what were the odds? Were we being visited more often, or had we simply been blind to the traffic until now? The discovery was announced, observatories coordinated, papers were drafted, and within weeks, some scientists would start suggesting that 3I Atlas wasn't a rock at all, that it was something else, something watching, something waiting, something that had been on its way here for a very, very long time. Let's talk about what 3I Atlas actually is, or what they say it is. When astronomers first spotted it, they had to figure out the basics. How big is it? What's it made of? How fast is it moving? These are simple questions with complicated answers, especially when the object is millions of miles away, and you're trying to measure something that might be smaller than a city block or larger than Manhattan. The numbers started coming in, and almost immediately, They didn't quite add up. Fact 11. Early estimates suggested the nucleus, the solid, icy core, was somewhere between 440 meters and 5.6 kilometers across. That's a massive range. 440 meters is about the length of 4 football fields. 5.6 kilometers is roughly 3.5 miles, the distance you could walk in an hour. The uncertainty comes from how brightness translates to size. If the object is very reflective, it could be small and still appear bright. If it's dark, absorbing most of the light that hits it, it would need to be much larger to produce the same brightness. Early observations from the Hubble Space Telescope tried to pin it down, but the answers kept shifting depending on what assumptions you made about the surface. Fact 12. Harvard astrophysicist Avi Loeb calculated that to avoid being pushed around by its own outgassing, 3I Atlas would need to be at least 5 kilometers wide, about the size of Manhattan Island. Here's where it gets interesting. When comets heat up near the sun, they release gas, mostly water vapor, carbon dioxide, carbon monoxide. This gas jets out from the surface, and like a tiny rocket engine, it pushes the comet around. Astronomers can measure this effect. It's called non-gravitational acceleration, and it's one of the key signatures that tell you you're looking at an active comet. But 3I Atlas didn't show this effect. Despite clear evidence of outgassing, despite gas and dust streaming off the surface, the object's trajectory stayed purely gravitational. No pushing. Loeb did the math. For an object to resist the rocket effect from its own gas jets, it would need to be extremely massive, dense, heavy enough that the outgassing couldn't move it. His calculations suggested a minimum diameter of 5 kilometers. Anything smaller, and the forces wouldn't balance. The object would show acceleration, but it didn't. Fact 13. Some estimates put the diameter closer to 20 kilometers, which would make it the largest interstellar object ever detected by orders of magnitude. 20 kilometers, 12.5 miles across. That's not a comet. That's a small world. For comparison, Oumuamua, the first interstellar visitor, was estimated at around 400 meters. 2I/Borisov, the second, was less than a kilometer. If 3I Atlas is really 20 kilometers wide, it's not just bigger, it's in a completely different category. And the statistics get uncomfortable. Large objects are exponentially rarer than small ones. The odds of seeing something this massive, arriving from interstellar space during the narrow window when we're able to detect it, are vanishingly small, too lucky to be luck, or too deliberate to be random. Fact 14. The object has a mass exceeding 33 billion tons, extraordinarily massive for what's supposed to be an icy comet. 33 billion tons. That's the mass of a small mountain, and it's just the lower limit, the minimum required to explain the lack of non-gravitational acceleration. The actual mass could be higher, much higher. This is not a fluffy snowball drifting through space. This is something solid, something dense, something that doesn't behave the way ice and rock should behave when the sun starts heating it up. Surrounding the nucleus is the coma, the cloud of gas and dust that gives comets their fuzzy appearance. Fact 15. Surrounding the nucleus is a coma, a cloud of gas and dust measuring between 13,000 and 26,000 kilometers across, roughly twice the diameter of Earth. Picture that. A halo of material larger than our entire planet, glowing softly in the reflected sunlight. The coma forms as the sun's heat warms the icy surface, causing frozen gases to sublimate directly from solid to vapor, carrying dust particles with them. It's the signature of an active comet, the visible proof that something is happening on the surface. And 3I Atlas had a coma, a big one. Fact 16. The coma grew steadily as 3I Atlas approached the sun, from 13,040 kilometers on June 21st to 18,760 kilometers by July 2nd. That growth is expected. The closer the object gets to the sun, the more heat it receives, the more ice sublimates, the bigger the coma becomes. Astronomers tracked the expansion using images from the Vera C. Rubin Observatory and the Gran Telescopio Canarias. Everything about the coma's behavior looked normal, predictable. the kind of steady growth you'd see in any comet approaching the Sunday. Except for what was inside it. Water vapor, hydroxyl ions, carbon dioxide, carbon monoxide, and organic compounds called tholins were all detected spewing from the object. The chemical analysis came from spectroscopy, splitting the light from the coma into its component wavelengths to see what elements and molecules are present. NASA's Swift Observatory detected hydroxyl, a breakdown product of water. The James Webb Space Telescope and SphereX found carbon dioxide and carbon monoxide. Gemini South and the NASA Infrared Telescope facility confirmed water ice. And the reddish color of the coma suggested the presence of tholins, complex organic molecules, created when simpler compounds are exposed to radiation over long periods of time. It's a normal mix for a comet. Water, carbon compounds, organics, the building blocks of chemistry, frozen for billions of years. But the proportions were off. Too much carbon dioxide, too early. And the way the light scattered through the dust wasn't quite right. Fact 18. 3. I-Atlas has a reddish color similar to D-type asteroids and trans-Neptunian objects, bodies from the cold outer reaches of solar systems. The color tells you about age and exposure. Objects that have been bathed in cosmic radiation for billions of years develop a reddish hue as the radiation breaks down surface materials into tholins. It's the color of ancient ice, of objects that formed far from any star, in the cold outer zones where planets barely exist. The color of 3 I-Atlas matched bodies from the Kuiper Belt, from the distant edge of our own solar system. But this object didn't come from our Kuiper Belt. It came from somewhere else, somewhere equally cold, equally old. Fact 19. The dust particles being ejected were unusually large, several micrometers in radius, with small grains moving at 22 meters per second and large grains at just 2 meters per second. Dust grain size matters. It tells you about the forces at work, about how the material is being released. Small grains are carried faster by gas pressure. Large grains move slowly, barely escaping the nucleus. The distribution observed in 3 I-Atlas suggested a mix of explosive release and gentle shedding, a combination that didn't quite match standard comet models. And then there was the tail, or rather, the absence of one. Fact 20. In some observations, particularly early ones, 3 I-Atlas showed no cometary tail at all, or stranger still, showed a tail pointing toward the sun instead of away from it. Comet tails point away from the Sunday always. That's basic physics. Solar radiation pressure and the solar wind push gas and dust away from the comet, creating the classic tail that streams behind the comet as it moves through space. But in July, when the Hubble Space Telescope photographed 3 I-Atlas, the image showed something unusual, a teardrop shape, a glow ahead of the nucleus, in the direction of motion, dust that seemed to be leading the object rather than trailing it. NASA scientists explained it as an artifact. The object was moving fast, and the exposure time was long enough that the motion blurred the image, creating the illusion of a forward-pointing tail. The background stars appeared as streaks, proof that the camera was tracking the comet's motion. Just an optical effect. Nothing strange. But others pointed out that the large dust grains, the ones moving at just 2 meters per second, wouldn't be blown back by solar radiation. They'd be too heavy. They'd drift forward, carried by the comet's momentum, creating exactly the kind of forward glow that Hubble captured. Not an artifact, a real feature. Dust behaving in a way that didn't quite fit the comet model. NASA called it a comet. Active, icy, normal. But piece by piece, 3 I-Atlas didn't quite act like one. The mass was too high. The acceleration was too low. The polarization was too strange. The color was too old. And the tail, when it appeared at all, pointed the wrong direction. By late July, some astronomers were starting to ask, what if it's not a comet? What if it's something else? Something that just looks like a comet from a distance, the way a wolf can look like a dog until you get close enough to see the eyes. Where 3 I-Atlas came from is strange. Where it's going is stranger still. When you plot the trajectory of an interstellar object, you're doing more than just tracking a dot moving across the sky. You're unwinding a story written in mathematics. Every curve, every angle, every slight deviation tells you something about the forces acting on the object, about where it's been and where it's headed. Most of the time, the story is simple. Gravity pulls. The object falls toward the sun, swings around it, and flies back out into space. A clean hyperbolic arc dictated by physics, predictable and natural. The trajectory of 3I Atlas told a different story. Fact 21. 3. I Atlas is traveling in a retrograde orbit, moving in the opposite direction to almost everything else in our solar system. Retrograde means backward, while the planets orbit the sun in one direction counterclockwise. If you're looking down from above the North Pole, 3I Atlas is moving the other way, clockwise, against the flow. It's not unheard of. Some comets from the Oort cloud, the distant shell of icy bodies surrounding our solar system, have retrograde orbits. But those comets were born here. They're part of the family, even if they move differently. 3I Atlas wasn't born here. It came from another star system, and somehow, it arrived moving backward relative to the architecture of our solar system. Why does that matter? Because most objects in interstellar space should have random orientations. Some prograde, some retrograde, distributed evenly. But the angle matters too. Fact 22. Its orbital plane is tilted just 4.89 degrees from the ecliptic, the flat disk where Earth and the other planets orbit the Sunday. The ecliptic is the plane of our solar system, the invisible disk where nearly everything orbits. The planets stay close to it, within a few degrees. Asteroids and comets from our system mostly stay near it too, because they all formed from the same rotating disk of gas and dust billions of years ago. But 3I Atlas didn't form here. It came from interstellar space, where there's no preferred direction, no natural reason to align with our ecliptic. And yet it did. 4.89 degrees, almost perfectly flat with the plane of our solar system. Fact 23. For a random interstellar object, the probability of arriving at such a shallow angle is estimated at less than 1%. Less than 1%. Avi Loeb did the math. If you pick a random direction in three-dimensional space and ask what the odds are that it aligns within 5 degrees of a specific plane, the answer is about 1 in 100, maybe less, depending on how you account for the velocity distribution of stars in the galaxy. It's not impossible. 1% chances happen, but they make you pause. They make you ask, is this luck, or is this something else? The trajectory gets stranger when you look at where it goes. Fact 24. 3. I Atlas's path takes it surprisingly close to Venus, Mars, and Jupiter, not colliding, but making approaches that seem almost planned. Close approaches to planets aren't unusual for objects passing through the inner solar system. Gravity bends trajectories. Encounters happen. But 3 approaches to 3 different planets, at distances close enough to be scientifically useful, but not so close as to cause gravitational deflection. That starts to look less like coincidence and more like intent. Fact 25. The probability of a random object passing this close to all 3 planets has been calculated at less than 0.005%. That's 5 in 100,000. The calculation comes from a paper co-authored by Loeb, analyzing the orbital geometry of 3I Atlas and the positions of the planets during its passage. They ran the numbers. They varied the entry time, the entry angle, the speed, and no matter how they adjusted the parameters, the odds of a random interstellar object threading this particular needle were vanishingly small. 5 in 100,000. The kind of odds that make astronomers uncomfortable. Fact 26. On October 3rd, 2025, it passed just 30 million kilometers from Mars, close enough for spacecraft orbiting the red planet to photograph it. 30 million kilometers sounds like a lot. It's about 80 times the distance from Earth to the Moon, but in solar system terms, it's close. Close enough that NASA's Mars Reconnaissance Orbiter, ESA's Mars Express, and the ExoMars Trace Gas Orbiter could all turn their cameras toward it and capture images at higher resolution than any Earth-based telescope could manage. Close enough that the passage was scheduled months in advance, observation windows carefully planned, instruments recalibrated. This was the best chance humanity would get to see 3I Atlas up close, and the timing, as we'll talk about later, coincided with something else, something that shut down those very observations. Fact 27. It will pass 97 million kilometers from Venus on November 3rd, and 54 million kilometers from Jupiter on March 16th, 2026. The Venus approach happens just days after perihelion, after 3I Atlas swings around the Sunday. By then, it will be moving even faster, accelerated by the Sun's gravity, racing outward. The Jupiter encounter comes months later, as the object exits the inner solar system. Jupiter's gravity will give it a final nudge, a gravitational slingshot that will add to its speed and send it back into the interstellar void. 3 planets, 3 approaches. A trajectory that touches the inner, middle, and outer zones of the solar system in sequence, like a carefully planned tour. NASA calls it coincidence, Loeb calls it optimal, and then there's the perihelion itself. Fact 28. 3. I Atlas will reach its closest point to the Sun perihelion on October 29, 2025, at a distance of 210 million kilometers, just inside the orbit of Mars. Perihelion is the critical moment for any comet. It's when the object gets the most heat, when the activity reaches maximum, when outgassing is strongest. It's also when the object is moving fastest, when gravitational forces are highest. For a natural comet, perihelion is just physics. For something with engines, with maneuvering capability, perihelion is opportunity. It's the moment when a small burn, a brief thrust, can produce the largest possible change in trajectory. It's called an Oberth maneuver, and it's one of the most efficient ways to change course in space. Fact 29. At that exact moment, it will be on the opposite side of the Sun from Earth, completely hidden from our view by the Sun's glare. Hidden. On October 29th, as 3I Atlas reaches perihelion, it will pass behind the Sun from Earth's perspective. No ground-based telescope will be able to see it. The glare from the Sun blocks everything in that direction. Space-based telescopes like Hubble and Webb won't be able to point there either. The Sun is too bright, too close. The risk of damaging sensitive instruments too high. For several days, maybe weeks, 3I Atlas will be invisible, moving through the most critical part of its trajectory where no one can watch. Loeb pointed out what could happen during that window. If the object is natural, it might fragment from thermal stress. Comets do that sometimes, breaking apart as the Sun heats them unevenly. We'd see the pieces when it emerged in November, a debris field instead of a single object. But if the object is artificial, if it has any capability to maneuver, perihelion is when it would act, a reverse Oberth maneuver. Fire engines against the direction of motion. Use the Sun's gravity well to maximize the deceleration. Drop into a bound orbit around the Sun instead of flying past. Deploy probes, release payloads, change the mission parameters. All hidden behind the Sun where no one can see. Fact 33. I Atlas is traveling at 137,000 miles per hour and will accelerate to speeds over 150,000 miles per hour as it swings around the Sun before exiting our solar system forever. 150,000 miles per hour, 42 kilometers per second, fast enough to cross the distance from Earth to the Moon in 2.5 hours. Fast enough that if it wanted to stop, if it wanted to stay, it would need to shed an enormous amount of velocity. And the only efficient place to do that is at perihelion, using the Sun's gravity to help. After perihelion, the object will be moving away, accelerating as it climbs out of the Sun's gravity well, headed back toward interstellar space, past Venus, past Earth, past Jupiter, and then gone, back into the dark between stars, traveling for billions of years until it reaches another system, another sun, another world with telescopes pointed at the sky. Unless it doesn't leave, unless something stays behind. The path of 3I Atlas traces a line that touches 3 planets, hides behind the sun, and exits at maximum speed. Mathematicians call it improbable. Avi Loeb calls it optimal. And the rest of us, watching from Earth, call it unsettling, because trajectories like this don't happen by accident. They happen because gravity is universal, because physics is predictable, because if you know where you're going and you plan the route carefully, you can thread the needle exactly. You can visit Mars, you can hide at perihelion, you can approach Jupiter. You can do all of it in one pass, efficiently, perfectly, like someone drew the path with a ruler and said, "This is how you survey a solar system without wasting time." Some objects pass through once and vanish. Others leave something behind. Every comet behaves a certain way. Ice heats up, gas jets out. The comet gets pushed around by its own exhaust. Every comet except this one. When astronomers study comets, they're looking at some of the most primitive objects in the solar system, frozen time capsules, unchanged since the early days of planetary formation. We know how they work. We've been watching them for centuries. Halley's Comet, Hale-Bopp, Neowise. They all follow the same patterns. They brighten as they approach the Sunday. They develop tails. They accelerate slightly from outgassing. The physics is well understood, predictable, textbook. 3I Atlas didn't read the textbook. Fact 31. Despite showing clear cometary activity, gas and dust streaming off the surface, 3I Atlas exhibits no detectable non-gravitational acceleration. No detectable non-gravitational acceleration. That phrase shows up repeatedly in the technical papers, and it's the thing that doesn't fit. When a comet releases gas, that gas carries momentum. It pushes, like a rocket engine firing in the opposite direction of the jet. Over time, over months of observation, this tiny push adds up. The comet's orbit changes, just slightly. The object arrives at predicted positions a little early or a little late. Astronomers measure this effect routinely. It's one of the ways we confirm an object is active, that it's really outgassing and not just reflecting sunlight. 3I Atlas showed clear signs of activity. The coma, the dust, the spectroscopic evidence of water vapor and carbon dioxide streaming away from the nucleus, all the signatures of outgassing. But the orbit stayed purely gravitational. No push, no drift, no acceleration. Fact 32. Normal comets get pushed by their own outgassing, causing small but measurable changes in their orbits, something called the rocket effect. The rocket effect is physics. You can't escape it. If you're ejecting mass in one direction, you move in the other direction. It's Newton's third law, playing out on an icy rock millions of miles from Earth. For typical comets, the effect is small but measurable. A few meters per second squared of acceleration, sustained over weeks or months. Enough to shift the orbit detectably. Enough that astronomers have to account for it when predicting where the comet will be months or years later. 3I Atlas ignored this. Its trajectory matched a purely gravitational path, as if the outgassing wasn't happening at all. As if the gas was being released in perfectly balanced jets, pushing equally in all directions, canceling out. Or as if the object was so massive that the push was negligible, too small to measure against the enormous inertia of the nucleus. For 3I Atlas to resist this force with its observed activity level, Loeb calculated it would need to be extraordinarily massive and dense. Extraordinarily massive. We talked about the 33 billion ton minimum earlier, but that's conservative. To completely suppress non-gravitational acceleration while releasing the amount of gas and dust observed in the coma, the object would need to be either far more massive than 33 billion tons, or it would need to have an interior structure that balances the forces perfectly. Either way, it's not behaving like a typical comet. It's behaving like something much heavier, much denser, much more solid than ice and rock should be. The physics don't quite add up, unless the composition is unusual, unless the structure is engineered. Then there's the way light bounces off it. Fact 34. Observations from the Very Large Telescope and Nordic Optical Telescope revealed that 3I Atlas shows an unusually high degree of negative polarization. The way light bounces off it is unlike any comet ever recorded. Polarization is a measure of how light waves are oriented after they scatter off a surface. When sunlight hits dust particles in a comet's coma, some of that light bounces back toward Earth. Depending on the size, shape, and composition of the dust grains, the reflected light becomes polarized. The electric field oscillates in a preferred direction instead of randomly. Astronomers measure this to learn about the dust, how big the particles are, what they're made of, how they're structured. Most comets show positive polarization at small phase angles, the angle between the Sun, the comet, and Earth. But 3I Atlas showed negative polarization, strong negative polarization, the kind of signature normally seen in trans-Neptunian objects, in frozen worlds from the outer edges of solar systems, where the dust has been processed by radiation for billions of years. It's rare, it's strange, and it's not what you expect from an active comet that's supposedly releasing fresh dust into space. Fact 35. The polarization signature more closely resembles trans-Neptunian objects, frozen worlds billions of miles from the Sun, than active comets. Trans-Neptunian objects are cold, old, undisturbed. They orbit beyond Neptune, in the Kuiper belt, where the Sun is just a bright star and temperatures hover near absolute zero. Their surfaces are ancient, irradiated, chemically altered by billions of years of exposure to cosmic rays. The dust on 3I Atlas shouldn't look like that. It should look fresh, newly released from the interior, pristine, but it doesn't. It looks old, processed, like it's been sitting in interstellar space, exposed to radiation, for longer than our solar system has existed. Fact 36. This suggests the dust particles have a composition and structure that shouldn't exist in a normal interstellar comet. Shouldn't exist. That's the phrase that keeps appearing in the scientific literature, buried in the careful language of peer-reviewed papers. The dust composition doesn't match standard models. The polarization doesn't fit the predictions. The behavior doesn't align with what we know about how comets work. Either 3I Atlas formed under conditions wildly different from anything we've observed, or the material itself is unusual, engineered maybe, designed to scatter light in a specific way, or simply ancient beyond comprehension, carrying the signature of processes we don't understand. Then there's the water. Fact 37. Ultraviolet observations from the Swift Observatory detected something unusual. The water signature was too strong, coming from an extended source rather than just the nucleus. Water in comets comes from ice sublimating off the nucleus. You expect to see a concentrated source, brightest near the center, fading as you move outward into the coma. But the Swift Observatory detected water signatures spread across a much larger region, extended, diffuse, as if the water wasn't just coming from the nucleus, but from smaller particles throughout the coma. Icy grains that were vaporizing far from the central body. Fact 38. Scientists theorized that small icy grains were being released and vaporizing far from the nucleus itself, a phenomenon seen in only a handful of distant comets. This is rare, very rare. It requires a specific structure of layered ices, materials that can fragment and release in chunks, rather than sublimating directly from the surface. It suggests that 3I Atlas has a complex interior, possibly with pockets of volatile ices embedded in a matrix of more stable material. Or it suggests active processes happening inside the object, releasing gas in controlled bursts, rather than steady evaporation. Either way, it's not standard, it's not simple. It's not what you expect from a billion-year-old snowball drifting through space. And then there's the timing of the activity itself. Fact 39. 3I Atlas remained unusually bright and active, even when it was 6.4 astronomical units from the Sun, far beyond where water ice should sublimate. 6.4 astronomical units. That's about 600 million miles from the Sun, well beyond the orbit of Mars, approaching the distance of Jupiter. At that distance, sunlight is weak, temperatures are frigid, Water ice should be stable, frozen solid, not sublimating at any significant rate. But 3I Atlas was active, bright, releasing material. NASA's test satellite caught it back in May, already showing a coma, already glowing. Fact 40. This suggests the activity was driven by more volatile ices like carbon dioxide or carbon monoxide, materials that evaporate at much lower temperatures. Carbon dioxide sublimates at much lower temperatures than water. If 3I Atlas is rich in these supervolatiles, it could remain active far from the sun, releasing gas and dust even in the cold outer solar system. Spectroscopy confirmed the presence of both compounds. The James Webb Space Telescope detected strong carbon dioxide emissions. SphereX saw carbon monoxide. So the explanation holds. The object is just unusually rich in volatiles, active at distances where water-dominated comets go dormant. But it's still unusual. Most comets are water-dominated. Carbon dioxide and carbon monoxide are present, but in smaller amounts. 3I Atlas seemed to be the opposite. Carbon-rich, water-poor, at least in the outer layers. A composition that suggests it formed in the very cold outer regions of whatever star system it came from. Or a composition that was carefully chosen, carefully balanced, to provide sustained activity across a wide range of distances from the Sunday. One anomaly you chalk up to measurement error. 2 anomalies. Maybe it's a weird comet. 8 anomalies. That's when scientists start asking uncomfortable questions. The missing rocket effect, the negative polarization, the extended water source, the early activity, the massive size, the reddish color, the forward-pointing dust, the perfect trajectory. One by one, these details piled up through the summer of 2025, each observation adding to the picture, each new data point making the standard explanations less convincing. By August, Avi Loeb had stopped calling it a comet. He was calling it an interstellar object. Neutral language, no assumptions. Just an object from another star system, passing through, exhibiting properties that didn't quite fit any category we had names for. And by September, he was calling it something else, something that would make headlines, something that would divide the scientific community and capture the public's imagination. He was calling it carefully, with calculations and caveats and peer-reviewed math, a possible technological artifact, a probe, a mothership, a visitor that came here on purpose. Dr. Abraham Avi Loeb is the head of Harvard's astronomy department, former chair of the Harvard Astronomy Department, and founder of the Galileo Project. He's published hundreds of papers, and he thinks 3I Atlas might be a spaceship. Not everyone agrees. In fact, most astronomers roll their eyes when his name comes up. They call him a provocateur, a headline chaser, someone who trades scientific credibility for media attention. They point to his history, his willingness to say things other scientists won't say, his comfort with controversy. But here's the thing about Avi Loeb. He's also one of the most accomplished astrophysicists in the world. His credentials are impeccable. His calculations are careful, and when he says something might be artificial, he's not guessing. He's showing you the math. Fact 41. Avi Loeb made headlines in 2018 when he suggested that Oumuamua, the first interstellar visitor, could be an alien light sail. Oumuamua, the first, the one that started everything. Discovered in October 2017, it tumbled through the inner solar system on a hyperbolic trajectory, moving too fast to be bound to the Sunday. It was odd from the start, elongated, possibly cigar-shaped, or maybe flat like a pancake, and it accelerated. Not much, but detectably, as if something was pushing it. Outgassing, most scientists said. A comet we just couldn't see the coma around. But Loeb did the numbers and suggested an alternative. What if it was a light sail? A thin reflective sheet, pushed by sunlight, accelerating without any need for propulsion. Artificial, designed, sent here maybe, or cast adrift from some long-dead civilization. The astronomy community pushed back hard. The media loved it, and Loeb doubled down. Fact 42. His 2021 book, Extraterrestrial, The First Sign of Intelligent Life Beyond Earth, argued that dismissing the possibility of alien technology is unscientific. The book laid out his case. Not that Oumuamua was definitely artificial, but that we should consider the possibility. That ruling it out without evidence was just as unscientific as insisting it was true without evidence. The principle of scientific inquiry is to follow the data wherever it leads, even if it leads somewhere uncomfortable, even if it suggests we're not alone, even if it suggests that interstellar objects might not all be rocks. The book became a bestseller. Loeb became a public figure. And when 3i Atlas appeared in the summer of 2025, he was ready. Fact 43. When 3i Atlas was discovered, Loeb immediately began calculating whether its characteristics matched a natural comet or something else. Within days of the July 1st discovery, Loeb was publishing essays, running simulations, comparing 3i Atlas to Oumuamua and Borisov. He looked at the trajectory, the size, the activity level, the lack of non-gravitational acceleration, the planetary alignments, and he started building a case, not a conclusion, not a claim, just a hypothesis, testable and falsifiable, the way science is supposed to work. Fact 44. In a peer-reviewed paper titled, Is the Interstellar Object 3i Atlas Alien Technology?, Loeb and colleagues outlined the hypothesis that 3i Atlas could be a technological artifact. The paper was published in July, co-authored with Adam Hibbard and Adam Crowell. It's not a speculative blog post. It's a technical analysis submitted to the academic journal archive, complete with orbital mechanics, probability calculations, and mission design software. The abstract is careful. It frames the hypothesis as largely a pedagogical exercise, a way to explore the implications if the object were artificial. But the analysis is serious, the numbers are real, and the conclusion is unsettling. The paper identifies 8 anomalies, 8 features of 3i Atlas that, taken together, suggest the object might not be natural, might be something else. Fact 45. The paper suggested that an advanced civilization interested in monitoring solar systems wouldn't send a probe that just flies through. Once they'd send a mothership. If you're an advanced civilization with the capability to send probes across interstellar distances, you don't waste resources on a single flyby. You don't launch a probe that spends billions of years traveling to a star system, takes a few pictures during a brief pass, and then leaves forever. That's inefficient. You send something that can stay, something that can observe over time, monitor changes, gather data from multiple locations. You send a mothership. Fact 46. This mothership could deploy mini-probes into orbit around the Sun, using the reverse solar Oberth maneuver to slow down and remain in our solar system. The Oberth maneuver is elegant physics. When you're deep in a gravity well, moving at high speed, a small thrust produces a large change in energy. Fire your engines at perihelion closest approach to the Sun, and you can either accelerate dramatically to escape velocity, or decelerate dramatically to drop into a bound orbit. For 3i Atlas, arriving at high speed on a hyperbolic trajectory, the optimal moment to brake and stay would be October 29th, perihelion, hidden behind the Sunday where no one can watch. The mothership doesn't need to stay itself. It just needs to deploy smaller objects, mini-probes, released with velocities carefully calculated to place them in stable orbits, around the Sunday, around planets, wherever observation is useful. Fact 47. The mini-probes could be small enough that even our best telescopes couldn't resolve them. They just look like cometary fragments. This is the clever part. If the mothership releases small objects 10 meters across, 1 meter across, even smaller, we wouldn't be able to see them individually. Not at the distances involved. They'd show up, if at all, as faint points of light, or as debris, or as nothing at all, lost in the glare and the noise of space. We'd assume they were chunks of ice, fragments broken off the main body, natural and unremarkable. We wouldn't know they were probes, We wouldn't know they were watching. And then Loeb took the idea further. Fact 48. Loeb further speculated that these mini-probes could be von Neumann probes, self-replicating machines that can create copies of themselves. Von Neumann probes are a theoretical concept, named after mathematician John von Neumann, who studied self-replicating systems. The idea is simple. You send a probe to another star system. The probe lands on an asteroid or moon, gathers raw materials, and builds copies of itself. Those copies travel to more star systems and repeat the process. Exponential growth. One probe becomes 2, becomes 4, becomes millions, spreading across the galaxy like seeds on the wind. It's the most efficient way to explore a galaxy. Send one, let it multiply. Wait. Fact 49. Self-replicating probes could spread throughout a solar system, or even throughout a galaxy, allowing a civilization to explore thousands of star systems simultaneously. Imagine you're a civilization that wants to map the galaxy. You could build millions of probes and launch them all individually, but that's resource intensive. Or you could build one, give it the ability to replicate, and let physics do the rest. Within a few million years, a blink of an eye on galactic timescales, your probes reach every star, every planet, every system with liquid water, with organic chemistry, with life. They watch, they record, they send data back, or they store it, or they simply exist as silent witnesses to the universe unfolding. If 3I Atlas is a mothership carrying von Neumann probes, we wouldn't see an invasion. We'd see what looks like a comet passing through, fragmenting naturally as it approaches the Sunday. And months later, we might notice small objects in unusual orbits, or we might not notice anything at all. Loeb wasn't claiming this is what's happening. He was laying out the scenario, step by step, showing that it's possible, that the observations fit, that if you wanted to survey a solar system without revealing yourself, this is how you'd do it. Fact 50. Loeb created a ranking system from 0 to 10, where 0 is definitely a natural comet, and 10 is definitely artificial. He ranked 3I Atlas as a 4, meaning 40% chance it's alien technology. The Loeb scale. 0 means natural, no question. 10 means artificial, confirmed beyond doubt. Loeb placed 3I Atlas at 4. Not halfway. Not a coin flip, but 40%, meaning he thought there was a better than 1 in 3 chance that the object is not a comet, that it's technology, that it's a probe from another civilization, executing a mission we can barely comprehend. That's not a fringe theory. That's a measured, calculated probability based on the data available as of August 2025. Loeb said he'd update the ranking as new information came in. If the object fragmented at perihelion, the ranking would drop towards 0. Natural comet, confirmed. But if it stayed intact, if it released smaller objects, if radio telescopes detected any signals, the ranking would climb toward 10. Where is it now, in October? Loeb hasn't updated the scale publicly. The Mars flyby images haven't been released. The perihelion pass is still ahead. We're in limbo, waiting for data that might never come, or that might change everything. Loeb's colleagues rolled their eyes. NASA released statements. Tom Statler, NASA's lead scientist for small solar system bodies, told reporters, "It looks like a comet. It does comet things. It very, very strongly resembles, in just about every way, the comets that we know." The message was clear. Move along. Nothing to see here, just a comet. But nobody could explain away all the numbers. The trajectory probability, the lack of non-gravitational acceleration, the polarization anomaly, the planetary alignments, each one individually could be dismissed. Coincidence, measurement error, unusual but not impossible. But together, they painted a picture that didn't quite fit the comet model. And the numbers, Loeb said, didn't lie. Physics doesn't care about comfort. It doesn't care if the answer is unsettling. The equations don't change because the result implies something extraordinary. Either the math works or it doesn't. And in this case, Loeb argued, the math worked better for an artificial object than for a natural one, not a fringe theory, a measured, calculated possibility. 40%. 4 out of 10 on a scale where 10 means confirmed alien technology. That's not a joke. That's not clickbait. That's a Harvard astrophysicist, with decades of experience and hundreds of publications, telling you that there's a significant chance, nearly half, that the object moving through our solar system right now is not a rock. It's a machine. On October 1st, 2025, the United States government ran out of money. 15,000 NASA employees were sent home. And 2 days later, 3I Atlas made its closest approach to Mars. The timing couldn't have been worse, or depending on your perspective, couldn't have been better. For months, astronomers had been planning the October 3rd observation window. Multiple spacecraft orbiting Mars, positioned to capture the closest, clearest images of 3I Atlas that humanity would ever get. The high-rise camera on the Mars Reconnaissance Orbiter could resolve details as small as 30 kilometers per pixel. ESA's Mars Express and ExoMars Trace Gas Orbiter were ready. China's Tianwen-1 was watching. The UAE's Hope Orbiter had its instruments calibrated. This was it, the moment when we'd finally see what 3I Atlas really was. And then Congress failed to pass a budget. Fact 51. The government shutdown began on October 1st, 2025, furloughing more than 15,000 NASA employees and freezing most agency operations. 15,000 people. Scientists, engineers, data analysts, communications staff, all sent home. Not because of a natural disaster. Not because of an emergency. Because politicians in Washington couldn't agree on spending priorities. Vice President J.D. Vance warned that the shutdown was imminent, blaming Democrats for holding the process hostage. Senate Majority Leader John Thune echoed the accusations. The standoff centered on healthcare subsidies and tax policy, disputes that had nothing to do with space exploration, but ground NASA operations to a halt anyway. Essential personnel stayed. The people who keep spacecraft alive, who maintain communication links, who prevent missions from dying in the vacuum of space. But everyone else went home, and the website went dark. October 3rd was the scheduled date for multiple NASA orbiters around Mars to capture the closest, most detailed images of 3I Atlas ever obtained. October 3rd, marked on calendars months in advance. Mission planners had worked out the timing, calculated the angles, programmed the cameras. Mars Reconnaissance Orbiter would capture high-resolution images during a 3-hour window as 3I Atlas passed through its field of view. Mars Express and ExoMars would gather spectroscopic data, measuring the composition of the coma. The Perseverance rover on the surface would photograph the object in the Martian sky. Everything was ready. And then the people who process that data, who convert raw numbers into images, who analyze and release the findings, were furloughed. Fact 53. The high-rise camera on the Mars Reconnaissance Orbiter can resolve objects as small as 30 kilometers per pixel, enough to determine the true size and structure of 3I. 30 kilometers per pixel. At the distance of the October 3rd flyby, that resolution would be enough to see structure, to distinguish between a single solid object and a cluster of fragments, to measure the nucleus directly instead of inferring its size from brightness. This was the observation that could settle the size question once and for all. 5 kilometers wide or 20, solid or fragmenting, one object or many. The cameras clicked, the data recorded. The spacecraft transmitted the information back to Earth, where it sat in digital storage, waiting for someone to process it, waiting for the shutdown to end. Fact 54. NASA's website displayed a message. Due to the lapse in federal government funding, NASA is not updating this website. The message appeared on October 1st. Bland, bureaucratic. Due to the lapse in federal government funding, NASA is not updating this website. No new images, no new press releases. No updates on ongoing missions. The usual stream of information, images from Mars rovers, data from space telescopes, educational content stopped. And the timing for anyone paying attention to 3I Atlas, was conspicuous. But here's where it gets strange. Fact 55. NASA initially stated that processing images from the Mars flyby would take several days, but within 24 hours, preliminary briefings were given to select media outlets. Several days. That was the official line. The data needs to be downloaded, processed, calibrated, analyzed. It's technical work that takes time. Except within 24 hours, reporters were getting briefings, not official press releases, not published papers, but background information, off-the-record conversations, preliminary findings shared with select journalists. And the message was consistent. It's a comet, nothing unusual, move along. Fact 56. These briefings characterized 3I Atlas as an ordinary comet without releasing any supporting images or technical data. Ordinary comet. That phrase appeared in multiple articles published on October 4th and 5th. The object behaves like a comet. It has all the characteristics of a comet. There's no reason to think it's anything other than a comet. Tom Statler from NASA gave quotes. European Space Agency officials made statements, all saying the same thing. Ordinary, natural, unremarkable, but no images, no data, no technical reports showing the measurements that led to these conclusions. Just statements, just assurances. Just trust us, it's fine. Fact 57. As of mid-October, no official high-resolution images from NASA's Mars orbiters have been released to the public. Mid-October, 2 weeks after the flyby. The shutdown ended on October 6th, 5 days after it started. NASA's website came back online. Normal operations resumed, but the Mars images, still not released. ESA published a few low-resolution views from ExoMars, showing a fuzzy white dot moving through space. But the high-resolution high-rise images, the ones that could show structure and detail, nothing. NASA's raw image archive, usually updated daily with new Mars reconnaissance orbiter data, showed a gap around October 3rd. Images from before, images from after. But the critical window, blank. Some said it's normal. Processing takes time, quality control, calibration, internal review before public release. But others pointed out that NASA has released images within hours when the stakes were high, when public interest demanded it. The first images from the James Webb Space Telescope, the Perseverance rover's first photos from Mars. When NASA wants to share something quickly, they can. So why the delay? Congresswoman Anna Paulina Luna personally contacted NASA Director Patrick Duffy to request that space-based telescopes be redirected toward 3I Atlas during the Mars approach. Anna Paulina Luna, representative from Florida, member of the House Committee on Oversight and Accountability, not someone typically involved in NASA mission planning, but she made a call. She reached out directly to NASA leadership during the shutdown and requested that telescopes be directed toward 3I Atlas, not a casual suggestion. A direct intervention from a member of Congress, pushing through bureaucratic inertia at a moment when the agency was supposed to be frozen. Fact 59. Her intervention resulted in observations that would have otherwise been skipped due to the shutdown images that still haven't been publicly released. The observations happened, the cameras pointed, the data was collected, and according to reports, it was Luna's direct involvement that made it happen. Without her call, those observations might have been postponed or canceled, collateral damage of the budget standoff, but she pushed. And NASA complied, and whatever those cameras saw, whatever data was collected during that window, remains classified or embargoed or simply unreleased. Luna appeared on news programs discussing 3I Atlas. She talked about the importance of monitoring interstellar objects. She didn't claim it was alien. She didn't speculate. She just said, "We need to be watching. We need to know what this is." And she made sure it happened. But she's not the only political figure who got involved. Representative Tim Burchett, also on the Oversight Committee, gave interviews about 3I Atlas. He talked about government transparency, about the public's right to know, about the importance of releasing data. And in one interview, Stephen Miller, Deputy Chief of Staff for Policy at the White House, was asked whether the president had been briefed on 3I Atlas. He didn't answer directly. He talked about the shutdown, about the budget negotiations, about the political standoff. But the question hung in the air. Does the president know? Has he been told? Is this a national security matter? And then there's the silence from agencies that weren't affected by the US shutdown. Fact 60. Multiple Mars orbiters. NASA's MRO. ESA's Mars Express and ExoMars TGO. China's Tianwen-1. And UAE's Hope orbiter all captured data on 3I Atlas during its flyby. Yet none of these agencies have released official processed images. 4 space agencies, 3 of them not subject to US government shutdowns. ESA is European. China's space program answers to Beijing, not Washington. The UAE's Hope mission is independent, and yet all of them remain silent. ESA released a few preliminary images, fuzzy dots, barely showing anything. But detailed analysis, high-resolution data, spectroscopic findings, nothing. Why? Coordination is possible. Space agencies collaborate. They share data. They agree on release schedules to maximize scientific impact. But coordination also suggests communication, agreement, perhaps even pressure. If one agency sees something unusual and the others want time to verify, to analyze, to understand the implications before going public, they might all agree to hold off, to wait, to keep the findings internal until everyone is ready. Or perhaps they all saw the same thing, something ordinary, a comet, as advertised. And there's no conspiracy, no cover-up, just the slow grinding process of peer review and technical validation. Images take time to process, papers take time to write. Science moves slowly, always has. But the silence from China is particularly notable. China's space program operates independently, often in competition with Western agencies. They release findings on their own schedule, announce discoveries when it benefits them politically. If Tianwen-1 captured clear images of 3I Atlas, images that showed it was just a comet, why not release them? Why not score a public relations win, showing Chinese space capabilities while Western agencies are hamstrung by budget politics? Unless the images show something that requires more careful handling, something that needs coordination, something that can't be announced unilaterally without causing problems. Avi Loeb was asked about the shutdown in an interview. Someone asked if he thought NASA was withholding information, if the silence was evidence of a cover-up. He laughed. He said the delay was a signature of terrestrial stupidity, not extraterrestrial intelligence. Bureaucracy, not conspiracy. Human incompetence, not alien intent. But then he added something else. He said that even if the probability of 3I Atlas being artificial is low, the cost of ignoring it is too high. That we should be treating this seriously, observing carefully, releasing data quickly. Because if there's even a chance, even a small chance that the object is not natural, then delays cost us information we can't get back. Windows close, opportunities pass, and once 3I Atlas moves behind the sun, once it disappears from view, we lose the ability to track it in real time. 7 spacecraft, 4 countries, dozens of cameras, and weeks later, the public had seen one blurry dot and a stack of rumors. Some called it bureaucracy, others called it a cover-up, but the silence, others noted, looked exactly like containment. Like the careful, coordinated response of agencies that saw something they couldn't immediately explain, something that required time to analyze, time to verify, time to figure out what to say and how to say it without causing panic or ridicule or international incidents. Or maybe it was just a comet, and the images, when they're finally released, will show exactly that, ice and rock, tumbling through space, unremarkable and ordinary. And all the speculation, all the conspiracy theories, all the questions about timing and silence will evaporate like morning fog under the sun's light. We'll know, eventually. When the data comes out, If the data comes out, August 15th, 1977, a radio telescope in Ohio picks up a signal from space. 72 seconds of pure, powerful transmission. And then silence. 48 years later, an object arrives from almost the same direction. It's one of the most famous unsolved mysteries in the search for extraterrestrial intelligence. Ask anyone with even a passing interest in aliens, in SETI, in the question of whether we're alone, and they'll know about the WOW signal. The brief, powerful radio burst that came from the constellation Sagittarius and never repeated. The signal that looked exactly like what we'd expect from an intelligent transmission. The signal that, despite decades of searching, has never been explained. And now, in 2025, an object is here. An interstellar visitor, coming from Sagittarius, moving through our solar system. And some people are asking, what if they're connected? Fact 61. On August 15th, 1977, the Big Ear radio telescope at Ohio State University detected a strong narrowband radio signal at 1420.456 MHz. The hydrogen line, the frequency many believe extraterrestrial civilizations would use to communicate. The hydrogen line. It's the most abundant element in the universe, and it emits radiation at a very specific frequency, 1420 MHz. If you're an alien civilization trying to send a message that other technological species will notice, you broadcast at the hydrogen line. It's the cosmic hailing frequency, the universal channel. Any civilization that builds radio telescopes will eventually tune to that frequency, because hydrogen is everywhere, fundamental to the structure of stars and galaxies. It's the obvious choice. And that's exactly where the signal appeared. Fact 62. The signal lasted exactly 72 seconds, the full duration that Big Ear's receiver could track that region of sky. Big Ear was a massive radio telescope, now demolished, that scanned the sky as Earth rotated beneath it. The telescope's field of view moved across the celestial sphere, and any given point in space remained visible for 72 seconds before rotating out of range. The signal lasted the entire duration. It appeared, remained strong and steady, and then vanished as the telescope's beam swept past, which means the signal could have been longer, could have continued after Big Ear lost line of sight. We only caught 72 seconds of what might have been a much longer transmission. Fact 63. Astronomer Jerry Eman, reviewing the data days later, circled the signal intensity reading 6EQUJ5 and wrote one word in the margin. Wow, 6EQUJ5. It looks like a code, like a message, but it's not. It's just the intensity of the signal over time, recorded in a format that uses letters and numbers to represent signal strength. 6 represents a certain intensity, E is stronger, Q stronger still, U near the peak, J falling back down, 5 weaker again. The pattern showed a signal that rose and fell as you'd expect from a point source moving through the telescope's beam. Natural, predictable, except for the intensity. The signal was strong, about 30 times stronger than the background noise, powerful enough that Eman, looking at the printout days later, immediately recognized it as extraordinary. He grabbed a red pen and circled the code, and in the margin, he wrote one word, wow, not a technical note, not a classification, just pure astonishment, wow. The name stuck. For 48 years, it's been the WOW signal, and despite countless follow-up observations, despite decades of scanning that same region of sky, at that same frequency, it has never repeated. The signal came from Sagittarius, the constellation that, from Earth's perspective, points toward the center of the Milky Way. A crowded region of space, dense with stars, home to the galactic core and all the exotic objects that cluster there, black holes, neutron stars, dense stellar nurseries, a place where extraordinary things happen. And now, 48 years later, an object has arrived from that same direction. Fact 64. The WOW signal originated from the constellation Sagittarius at coordinates RA equals 19 hours 25 minutes. Declination equals minus 27 degrees. Coordinates are addresses in the sky. Right ascension and declination, the celestial equivalent of longitude and latitude. 19 hours, 25 minutes right ascension, minus 27 degrees declination. That's where Big Ear was pointed when the signal came through. Not a precise point, the telescope's beam covered an area of sky, and the exact source location has some uncertainty. But the general direction is clear: Sagittarius, the galactic center region. So where was 3I Atlas in August 1977? Fact 65. On August 12, 1977, 3 days before the signal reached Earth, 3I Atlas was located at approximately R. A equals 19 hours 40 minutes. Declination equals minus 19 degrees. 3 days earlier, the signal would have taken 3 days to travel from 3I Atlas to Earth at that distance, moving at the speed of light. And the coordinates are close. 19 hours 25 minutes versus 19 hours 40 minutes in right ascension. Minus 27 degrees versus minus 19 degrees in declination. Not exact, but close. The two positions were separated by approximately 4 degrees in right ascension and 8 degrees in declination. A chance alignment, probability of about 0.6. 0.6%, less than 1 in 100. Avi Loeb ran the numbers. He calculated the solid angle, the three-dimensional probability that two random directions in space would align this closely. And the answer came back at around 0.6%. Not impossible. 1 in 100 chances happen, but they make you pause. They make you ask whether it's really random or whether there's a connection. The skeptical explanation is straightforward. Sagittarius is a large constellation. It's one of the richest regions of sky for interesting objects and phenomena. If you're going to detect a mysterious radio signal, Sagittarius is a likely place. And if an interstellar object happens to arrive from the galactic center region, that's not surprising either. That's where the stars are densest, where ejection events are most common. The alignment is coincidence, nothing more. But Loeb wondered, what if it's not? Fact 67. In August 1977, 3I Atlas was approximately 600 astronomical units from Earth, about 600 times the distance from Earth to the Sunday. 600 astronomical units. That's about 56 billion miles, about 4 times the distance to Pluto. Deep in the outer solar system, or technically still in interstellar space, approaching the solar system, depending on how you define the boundary. At that distance, sunlight is incredibly faint. Temperatures are just a few degrees above absolute zero. It's the realm of the Oort cloud, the distant shell of comets that marks the edge of the sun's gravitational influence. For a signal to travel from 600 AU to Earth and arrive with the intensity that Big Ear detected, it would need to be powerful. Fact 68. For a transmitter at that distance to produce the intensity of the WOW signal, it would require a power output between 0.5 and 2 gigawatts, equivalent to a nuclear reactor on Earth. Between half a gigawatt and 2 gigawatts. That's the power output of a large nuclear power plant, not a transmitter you'd carry in your pocket. Not something that runs on batteries. A gigawatt is 1 billion watts, the kind of power that requires industrial-scale infrastructure. On Earth, we generate that kind of power with nuclear reactors, massive hydroelectric dams, or fields of solar panels covering square miles. Could a comet generate that kind of power? No. Comets are passive. They don't have power plants. They don't generate electricity. They're chunks of ice and rock, warmed by the sun, releasing gas through sublimation. No power source, no transmitters. No way to broadcast a radio signal at gigawatt levels. Could something artificial generate that kind of power? Yes, easily. A nuclear reactor, a fusion plant, some exotic power source we haven't invented yet. If you wanted to send a signal, if you wanted to announce your presence or communicate with someone, you'd need power. And gigawatt-scale power is achievable with the right technology. The signal was never heard again. Fact 69. Despite decades of follow-up observations, the WOW signal has never repeated, and no similar signal has ever been detected from that region of space. Jerry Eamon went back to Big Ear the next night. He pointed the telescope at the same coordinates, listened at the same frequency. Nothing. He tried again the next night. Nothing. For months, he and his colleagues at Ohio State monitored that region whenever it was visible. Silence. Other telescopes joined the search. Bigger dishes, more sensitive receivers, longer observation times, all came up empty. In 2012, on the 35th anniversary of the signal, the Arecibo Observatory in Puerto Rico transmitted a response toward the coordinates. A collection of Twitter messages, video clips, a deliberate attempt to say, "We got your message, here's ours." The transmission was symbolic, a gesture, an acknowledgement of the mystery, but no response came back. Fact 70. Some scientists proposed the signal came from a passing comet, but that hypothesis was dismissed because comets don't emit radio waves at those frequencies or intensities. In 2017, a researcher named Antonio Paris suggested that the signal could have been caused by a comet. Specifically, comets 266P/Christensen or 335P/Gibbs, which were in that region of sky in 1977. Comets have hydrogen clouds, he argued. Maybe the hydrogen emitted at the right frequency, producing the signal. The hypothesis was immediately debunked. Comets don't emit strong radio signals at the hydrogen line. They can absorb and re-radiate sunlight at certain wavelengths, but not in the radio spectrum, and not at the intensity observed. Moreover, the sighted comets weren't in the right position at the right time. The math didn't work. The physics didn't work. The explanation was rejected by the original Big Ear team and by the broader astronomy community. So the mystery remained. A powerful, narrowband radio signal at the universal hailing frequency, lasting at least 72 seconds, coming from the direction of the galactic center, never repeating. No natural explanation fits. No artificial explanation has been confirmed, until, maybe, now. Loeb laid it out carefully. If 3I Atlas transmitted the WOW signal in 1977, it would have been 600 AU away, deep in the outer solar system or just beyond. The object has been approaching ever since, taking 48 years to travel from the edge of the solar system to its current position inside the orbit of Mars. The timing works, the trajectory works. The power requirements, while extreme, are achievable for a technological artifact. It's not proof. It's a hypothesis. A possible connection between two unexplained phenomena separated by 48 years. But the probability of the alignment, the 0.6% chance that the coordinates match so closely, suggests it's worth considering, worth investigating, worth pointing radio telescopes at 3I Atlas and listening. Loeb urged radio observatories to do exactly that. Point your dishes at 3I Atlas, listen at 1420 MHz, at the hydrogen line. See if the object is transmitting. See if the whisper from 1977 might speak again. So far, no one has reported any results. Either no one is listening, or they're listening and hearing nothing, or they're listening and hearing something they're not ready to share. The Sagittarius connection, the WOW signal origin, the interstellar visitor arriving decades later from the same direction. Coincidence, probably. Statistics tell us that unlikely things happen, that 1 in 100 chances occur one time out of 100, that we shouldn't read meaning into every correlation. But the 0.6% probability nags at you. It sits in the back of your mind, whispering. And when you combine it with everything else, the trajectory, the anomalies, the missing rocket effect, the government shutdown, the unreleased images, it becomes one more piece of a puzzle that doesn't quite fit together. Unless the source was moving, unless the signal wasn't coming from a star or a planet or a fixed point in space, unless it was coming from an object, traveling through the void, broadcasting as it approached. A beacon, a greeting, a warning. And now it's here. October 3rd, 2025. 3I Atlas passed within 30 million kilometers of Mars. 7 spacecraft with cameras were watching, and then the data went dark. This was supposed to be the moment, the observation that would settle everything. After months of speculation, of calculations and theories, of debates about whether the object was natural or artificial, we'd finally get close-up images. Not from Earth, where atmospheric distortion and vast distances limit what we can see. From Mars. From spacecraft already in position, orbiting the red planet, equipped with high-resolution cameras designed to photograph surface features from hundreds of miles away. If those cameras turned toward 3I Atlas during its closest approach, they should have captured details, structure, texture, proof of what the object really is. The observation window was planned months in advance. Mission teams coordinated, spacecraft were programmed, everything was ready. And then the silence. Fact 71. Between October 1st and October 7th, ESA's Mars Express and ExoMars Trace Gas Orbiter were scheduled to observe 3I Atlas as it made its closest approach to Mars. The European Space Agency has 2 orbiters at Mars: Mars Express, which has been there since 2003, and the ExoMars Trace Gas Orbiter, which arrived in 2016. Both carry cameras, both carry spectrometers. They're designed to study Mars, its surface, its atmosphere, its geology. But cameras are cameras. Point them at something else, and they'll photograph it. Point them at an interstellar visitor, passing 30 million kilometers away, and they'll capture what they can. ESA planned the observations carefully. The geometry was tricky. The object was far away, moving fast, faint against the background stars. But the cameras could track it. The spectrometers could analyze the light. Over the course of a week, from October 1st through October 7th, the spacecraft would gather data whenever 3I Atlas was in view. Fact 72. The CASSIS camera on ExoMars TGO captured images showing a slightly fuzzy white dot moving through space, the closest view any spacecraft would get. CASSIS, the Color and Stereo Surface Imaging System, a camera designed to photograph the Martian surface in color and 3 dimensions, to capture geological features, to study craters and valleys and ancient riverbeds. Not designed to photograph distant comets, but it tried anyway. The images were released in early October, a series of frames showing a small, fuzzy white dot moving against the black background of space. You can see the coma, the hazy cloud of gas and dust surrounding the nucleus. You can see motion, the object shifting position frame by frame as it moved through the field of view. But you can't see detail. You can't see structure. You can't tell if the nucleus is one solid object or a cluster of fragments. It's too far away, too faint, too small. ESA was upfront about the limitations. The coma surrounding 3I Atlas was clearly visible in the images, measuring several thousand kilometers across, but the nucleus itself could not be resolved. The coma is big, thousands of kilometers across. At the distance of 30 million kilometers, that's still large enough to show up as a fuzzy glow. But the nucleus, the solid core, is only a few kilometers wide at most, maybe less. And at 30 million kilometers, even the best cameras on Mars orbiters can't resolve something that small. Fact 74. ESA stated that imaging the 1-kilometer nucleus at that distance would be as impossible as seeing a mobile phone on the moon from Earth. A mobile phone on the moon. That's the analogy ESA used. From Earth, the moon is about 380,000 kilometers away. A mobile phone is about 15 centimeters long. The angular size is impossibly small. You'd need a telescope with a mirror, hundreds of meters across, to resolve something that tiny at that distance. The cameras on Mars orbiters are good, but they're not that good. They're designed for photographing a planet from a few hundred kilometers away, not for resolving kilometer-sized objects at distances of millions of kilometers. So the official images showed a fuzzy dot, useful for confirming the object's position, for tracking its motion, for measuring the coma's brightness, but not useful for answering the big questions, not useful for determining size, structure, composition, not useful for settling whether it's a rock or something else. But there were other cameras watching. Fact 75. On October 1st, NASA's Perseverance rover on Mars captured raw images of the night sky that some analysts claimed showed a faint smudge in the constellation Corona. Perseverance, the rover that landed in Jezero crater in February 2021, searching for signs of ancient microbial life, drilling rock samples, exploring the Martian surface. It has cameras that look up as well as around. Navigation cameras that photograph the sky to track the sun and stars, to help orient the rover, to capture atmospheric phenomena. And on the night of October 1st, those cameras were pointed up. The raw images were posted to NASA's public archive. Anyone can access them. And someone did. An astrophotographer named Simeon Schmaus downloaded the images and started processing them. Astrophotographer Simeon Schmaus stacked 20 images from Perseverance's Mastcam Z and reported finding 3I Atlas in the predicted location, but NASA never confirmed the identification. Image stacking is a common technique. You take multiple photos of the same scene and combine them, averaging out the noise, enhancing faint signals that would be invisible in a single frame. Schmaus took 20 images from Perseverance, aligned them, stacked them, and in the resulting composite, he found a faint smudge of light, right where 3I Atlas should have been, based on orbital predictions, right in Corona Borealis, just above the Martian horizon. He posted the finding on social media. I think Perseverance may have spotted interstellar comet 3I Atlas last night from Mars, he wrote. The image made the rounds. Astronomers looked at it. Some said it could be the comet. Others said it could be noise, an artifact, a cosmic ray hit, anything. Without confirmation from NASA, without official analysis, it remained speculation. NASA never commented. The image exists in the public archive. The smudge is there. But whether it's 3I Atlas or something else, officially we don't know. Then there's the future observation window. Fact 77. ESA's JUICE spacecraft, currently en route to Jupiter, will attempt to observe 3I Atlas in November 2025 using multiple instruments, including cameras and ultraviolet spectrographs. JUICE, the Jupiter Icy Moons Explorer, launched in April 2023, now on its way to the outer solar system to study Jupiter's moons, Europa, Ganymede, Callisto. It's equipped with powerful instruments, cameras that can photograph objects millions of kilometers away, spectrographs that can analyze the composition of gas clouds, particle sensors that can measure the solar wind and interplanetary dust. And in November, it will have a view of 3I Atlas, not as close as the Mars orbiters. JUICE will be much farther away, roughly 125 million kilometers from the object. But the viewing geometry will be different, and the timing matters. Fact 78. JUICE will see 3I Atlas just after its perihelion pass, when it should be at maximum activity, potentially fragmenting, potentially deploying something. November, after perihelion. After the object swings around the sun, heats up, reaches maximum temperature and stress. If it's going to fragment, that's when it would happen. If it's going to release anything, mini probes, debris, whatever, that's the window. And JUICE will be watching. The observations are scheduled for November 2nd through November 25th. 3 weeks of monitoring. Tracking the object as it moves away from the sun. Watching for changes. Looking for fragments or anomalies or anything unexpected. But there's a catch. The data won't be available immediately. JUICE is far from Earth. Communications are slow. The spacecraft's high-gain antenna is currently being used as a heat shield, protecting instruments from the sunday. Data is being transmitted through a smaller, slower antenna, and the processing, the analysis, the verification, all of that takes time. ESA has said the data from JUICE's November observations won't be released until February 2026. 3 months after the observations, 3 months of waiting, 3 months of wondering what JUICE saw and whether it will confirm or contradict the comet hypothesis. Then there are the agencies that haven't said anything at all. Fact 79. China's Tianwen-1 orbiter, equipped with high-resolution cameras and spectrometers, was also positioned to observe 3I Atlas during the Mars flyby. China doesn't publish everything. Their space program operates with less transparency than NASA or ESA. Findings are released when it's politically advantageous, when the data has been thoroughly analyzed, when Beijing decides it's time. Tianwen-1 reached Mars in February 2021. It has a high-resolution camera capable of capturing surface details, and it had a view of 3I Atlas in early October. But no images have been released. No statements have been made. Nothing in the Chinese scientific literature or state media about the observations. Just silence. Fact 80. The UAE's HOPE orbiter, with its infrared and ultraviolet instruments, captured data as well, but like NASA and ESA, neither China nor the UAE have released official findings. The UAE's HOPE orbiter arrived at Mars in February 2021. It's the Arab world's first interplanetary mission, designed to study the Martian atmosphere in unprecedented detail. It carries infrared and ultraviolet spectrometers, instruments that can see wavelengths invisible to human eyes, that can detect gases and measure temperatures and track atmospheric dynamics. HOPE was in position to observe 3I Atlas. The instruments were capable. The data was collected. And like China, like NASA, like ESA, the UAE hasn't released anything. No papers, no press releases, no images. Just the same coordinated silence. 4 space agencies, 7 spacecraft. October 3rd came and went. The closest approach happened. The cameras clicked. The data recorded. And weeks later, the public has seen one fuzzy dot from ESA and a possible smudge from Perseverance stacked images. Nothing from NASA's high-resolution cameras. Nothing from China. Nothing from the UAE. Technical processing, they say. Quality control. Peer review. Internal analysis before public release. All normal, all routine. Nothing to worry about. But the timing nags. The shutdown that coincided with the flyby. The rushed briefings declaring it a normal comet without showing the images. The gaps in the raw data archives. The coordination across multiple countries, multiple agencies, all staying quiet at the same time. Maybe they're being careful. Maybe the images show something ambiguous, something that requires expert interpretation, something that could be misunderstood if released without context. Maybe they're waiting for academic papers to be written, for peer review to be completed, for the proper scientific process to run its course before making claims. Or maybe they saw something they can't explain, something that doesn't fit, something that requires more observation, more data, more time to understand before announcing to the world. 7 spacecraft, 4 countries, dozens of cameras, and weeks later, the public had seen one blurry dot and a stack of rumors. Some called it bureaucracy. Others called it a cover-up. But the silence looked exactly like containment, like the careful, measured response of agencies that saw something unexpected and decided, collectively, that rushing to release incomplete data would cause more problems than solutions, that patience was prudent, that certainty was worth waiting for. Or maybe there's nothing to contain. Maybe the images, when they're released, will show exactly what NASA said. A comet, ice and rock, natural and ordinary, and all the speculation will evaporate, proven wrong by simple photographs. We'll know, eventually, when February comes and JUICE's data is released, when the Mars orbiter images are finally published, when the academic papers make it through peer review and appear in journals. If they appear, if the data comes out, if the silence ever breaks. Avi Loeb published a calculation. If 3I Atlas is artificial, and if it uses the perihelion pass to break into our solar system, it could reach Earth between November 21st and December 5th, 2025. That's not a warning. That's a timetable. Most scientists dismissed it. Most people didn't hear about it at all. But for those paying attention, for those reading Loeb's blog posts and technical papers, The dates hung in the air like a deadline. October 29th, perihelion. The object disappears behind the Sunday. And then November. Late November through early December. The window when deployed probes could reach Earth orbit if they're using optimal trajectories. It's speculative. It's based on assumptions that most astronomers reject. But the math is there. The trajectories work. And if there's even a small chance, even a fraction of a percent, that the object is not natural, then humanity is facing a moment without precedent. First contact. Not with radio signals from distant stars, with something physical. Something here. Something in our backyard, and we have no plan. Fact 81. Loeb and colleagues invoked the dark forest hypothesis, a solution to the Fermi paradox, suggesting that advanced civilizations stay silent to avoid detection by hostile aliens. The Fermi paradox asks a simple question. If the universe is vast and old, if there are billions of stars with planets, if life can arise anywhere conditions are right, then where is everyone? Why haven't we detected alien civilizations? Why is the galaxy silent? The dark forest hypothesis offers a dark answer. Maybe civilizations don't broadcast because broadcasting is dangerous. Maybe the galaxy is full of predators, advanced species that eliminate competitors before they become threats. Maybe survival means staying quiet, staying hidden, revealing nothing. The moment you announce your presence, you become a target. The hypothesis takes its name from a Chinese science fiction novel, but the logic is ancient. When you're alone in a dark forest, you don't shout, you don't light a fire. You move quietly, watching for threats, because anything else could be listening. Fact 82. Under this theory, any civilization that reveals itself risks attack, making first contact potentially dangerous for both parties. If the dark forest is real, then encountering another civilization is not a moment of celebration. It's a moment of existential risk. You don't know their intentions. They don't know yours. Both of you are potential threats. And the rational response, the one that maximizes survival, is preemptive action. Strike first. Eliminate the threat before it can eliminate you. It's game theory applied to galactic scale conflict. Trust is impossible. Communication is risky. The only safe civilization is a dead civilization. Fact 83. If 3i Atlas were a probe from a civilization following dark forest principles, it might be surveilling us without announcing its presence or preparing to eliminate a potential future threat. Surveillance first. Assessment. Gather data on the technological level, the military capabilities, the potential for future expansion. Watch silently from a distance, from orbits where detection is unlikely, using instruments we can't detect with our current technology, and then decide, are they a threat? Will they become one? Do they need to be neutralized now? Or can they be monitored longer? The decision wouldn't be made by the probe. It would report back, transmit findings across light years to whoever sent it, and await instructions. Or maybe the instructions were programmed in advance. Assess, decide, act. Loeb's paper acknowledged this possibility, not as a prediction, but as a scenario that should be considered. If the object is artificial, if it's here with intent, we can't assume that intent is benign. We need to prepare for the possibility that it's hostile, that we're being judged, that the outcome could be devastating. The mechanics of an attack, should it come, would leverage physics we understand well. Fact 84. A solar Oberth maneuver involves using the sun's gravity to either accelerate or decelerate by firing engines at perihelion. A spacecraft can dramatically change its trajectory with minimal fuel. The Oberth effect is elegant. When you're moving fast through a gravity well, kinetic energy is high. A small thrust at that moment produces a large change in total energy. It's the reason spacecraft use gravity assists. Swing close to a planet, fire engines at closest approach, and you can change course dramatically with less fuel than it would take in empty space. For 3i Atlas, arriving on a hyperbolic trajectory, the optimal moment to decelerate and stay in the solar system is perihelion. Fire engines against the direction of motion when the object is closest to the sun and moving fastest. The gravity well amplifies the effect. What would take enormous thrust in interstellar space requires much less at perihelion. Fact 85. October 29th, when 3I Atlas reaches perihelion, is the optimal point to perform such a maneuver, and it will be completely hidden from Earth's view behind the Sunday. Hidden. That's the key word. Perihelion happens on the far side of the sun from Earth's perspective. No ground-based telescope can see it. No space telescope can point in that direction without risking damage from solar glare. For days, maybe weeks, the object will be invisible. If it's going to maneuver, that's when. If it's going to deploy probes, that's when. If it's going to change from a visitor to a resident, from an observer to an actor, that's the window, and we can't watch. By the time 3I Atlas re-emerges in late November, it will either be on its way out of the solar system, trajectory unchanged, confirming it's just a comet, or it will be in a different orbit. Slower, bound to the Sunday, accompanied by smaller objects that weren't there before, and we won't know until it's already happened. Meanwhile, the institutions that should be preparing aren't. Fact 86. In October 2025, Loeb called on the United Nations Office for Outer Space Affairs to establish formal protocols for responding to interstellar objects that might be artificial. UNOSA, the United Nations Office responsible for international cooperation in space. They maintain treaties, coordinate satellite registrations, manage agreements about planetary protection and space debris. But they have no protocols for alien technology. No framework for what to do if an interstellar object turns out to be a probe. No agreed-upon response for how humanity should react. Loeb's white paper was direct. The visitor is already in our yard. The time for abstract policy discussions is over. We need concrete plans. Who makes decisions? Who speaks for humanity? What do we do if the object is confirmed as artificial? What if it deploys probes? What if it approaches Earth? What if it communicates? Fact 87. Currently, no international framework exists for how humanity should respond to the discovery of alien technology in our solar system. We have asteroid deflection plans. NASA tracks near-Earth objects, calculates impact probabilities, designs missions to redirect threatening asteroids. We have planetary protection protocols to prevent biological contamination when we send missions to other worlds. We have treaties governing weapons in space and the use of nuclear devices beyond Earth's atmosphere. But we have nothing for this. Nothing for the scenario where an object from another star system turns out to be artificial. Nothing for first contact that doesn't come as a radio signal, but as a physical presence. The oversight is stunning when you think about it. We've been searching for extraterrestrial intelligence for decades, scanning the skies with radio telescopes, but we never developed protocols for what to do if we actually find something. Fact 88. Loeb submitted a white paper arguing that the visitor is already in our yard, and that waiting to develop a response plan could be catastrophic. Already in our yard, not approaching, not decades or centuries away, here, now, moving through the solar system. And the lack of preparation, the absence of protocols, the vacuum where policy should exist, is itself a vulnerability. Loeb's argument was pragmatic. Even if the probability is low, even if 3I Atlas is almost certainly natural, the stakes are too high to ignore. If there's even a 1% chance that the object is artificial and potentially hostile, then the expected value of preparing, of having plans, having responses, having international coordination is enormous. It's the same logic we apply to asteroid impacts. The probability of a civilization-ending asteroid strike in any given year is very low. But the consequences are so severe that we spend resources tracking and preparing anyway. We don't wait for the asteroid to be on a collision course before developing deflection technology. We prepare in advance. Why should alien probes be any different? The silence from institutions has been deafening. The UN hasn't responded publicly. National space agencies haven't announced policy changes. No international meetings have been called. No working groups formed. Either they don't take the possibility seriously, or they're having discussions behind closed doors that the public isn't privy to. And then there's the silence from an unexpected quarter. Fact 89. Despite owning SpaceX, Starlink, and having more space-capable infrastructure than most governments, Elon Musk has remained publicly silent about 3I Atlas. Elon Musk, the man who tweets about everything, who comments on AI development, on Mars colonization, on tunnels and brain implants, and whatever crosses his mind on any given day, who has more satellites in orbit than most countries, who runs the most capable private space launch company in the world, who has the resources and infrastructure to observe 3I Atlas independently, to point telescopes at it, to analyze data without waiting for government agencies. Fact 90. Some asked why Musk, who regularly comments on space topics and AI threats, hasn't used his satellite network or telescopes to observe and share data on the most significant interstellar visitor in human history. The Starlink network could be repurposed. Ground stations could track the object. Data could be shared publicly. Musk has the capability to launch missions on short notice, to redirect satellites, to coordinate observations. He's done it before for other purposes. But on 3I Atlas, nothing. No tweets, no announcements, no observations shared, just silence. Some speculated he doesn't care, that interstellar visitors don't interest him as much as Mars colonization or artificial intelligence, that his attention is elsewhere. Others speculated he's been told to stay quiet, that government agencies, aware of his capabilities and his tendency to share information publicly, asked him to hold off, to let official channels handle the communication, to avoid complicating an already complex situation. Or maybe he knows something. Maybe SpaceX has observed the object. Maybe the data shows something that confirms it's just a comet, making public commentary unnecessary. Or maybe it shows something else, something that requires careful handling, something that can't be tweeted. We don't know. And the silence itself becomes part of the mystery. Loeb told reporters, "It could come to save us or to destroy us. We'd better be prepared for both possibilities." The quote made headlines. Critics called it fear-mongering. Supporters called it prudent risk assessment. But either way, it captured the uncertainty. We don't know what 3I Atlas is. We don't know what happens next. And the institutions that should be coordinating a response, the ones with the resources, the authority, the international reach to manage a situation like this, are either unprepared or unwilling to acknowledge the possibility publicly. The problem, Loeb argued, isn't just about 3I Atlas. It's about what comes after. If this object turns out to be natural, fine. We learn. We move on. But what about the next one? What about 4I, 5I, 10I? Interstellar objects are arriving more frequently now, or at least we're detecting them more frequently. And each one could be natural, or one of them might not be. Without protocols, without plans, without international coordination, we're vulnerable, not to invasion necessarily, but to chaos, to conflicting responses, to nations acting unilaterally because there's no framework for collective action. And the window is closing. October 29th is days away. Perihelion. The moment when 3I Atlas disappears behind the Sunday. The moment when, if Loeb is right, everything could change. And we're not ready. 3I Atlas is still out there. Right now, as you listen to this, it's moving through the darkness beyond Mars, approaching the sun, approaching the moment when we'll either have answers or more questions. We've walked through 100 facts, discovery to trajectory, anomalies to hypotheses, government shutdowns to unanswered signals. Each fact adds to the picture, but the picture remains incomplete, blurred at the edges, open to interpretation, and the biggest questions, the ones that matter most, remain unanswered. Fact 91. We don't know the exact size of 3I Atlas. Estimates range from 5 to 20 kilometers, a difference that changes everything about its nature and origin. 5 kilometers or 20. One is unusual, the other is impossible. If the object is 5 kilometers across, It's large but not unprecedented. Comets that size exist. They're rare, but they're within the statistical bounds of what we expect from planetary system formation and ejection processes. 5 kilometers means it's an interesting object, worth studying, scientifically valuable, but natural. 20 kilometers changes everything. Objects that large are exponentially rarer. The probability of detecting one during the brief window, when we have the technology to see them, becomes vanishingly small. 20 kilometers means we're either extraordinarily lucky, or the object's presence isn't random. It's deliberate. It's here for a reason. The size determines the mass. The mass determines whether the lack of non-gravitational acceleration makes sense. The calculations cascade. And we still don't have a definitive answer. The Mars flyby should have given us one. HiRISE should have resolved the nucleus, measured its dimensions, settled the question. But the images haven't been released. The answer remains locked behind processing delays, peer review, government protocols, or behind something else. Fact 92. We don't know what's inside it, whether it's solid ice and rock, or whether there could be internal structure, chambers, machinery. What's inside matters. A natural comet is a rubble pile, a loose collection of ice and rock held together by weak gravity, porous and fragile. We know this from missions to comets in our own solar system. Rosetta landed on comet 67P/Churyumov-Gerasimenko. It's a lumpy, irregular object with the density of cork. Fragile, breakable. 3I Atlas, if the mass estimates are correct, is much denser, much more solid. That could mean it's a rare type of comet, compressed by billions of years in interstellar space, or subjected to processes we don't fully understand. Or it could mean the interior is structured, compartmentalized, built rather than accreted. We can't see inside. We don't have the technology to scan the interior of an object millions of miles away. Radar could do it at close range, but no spacecraft is close enough. Seismic measurements could reveal internal structure, but you'd need to land on the surface and deploy instruments. The only way to know is to go there, to send a mission. And there's no time. The object is already too far, moving too fast, on a trajectory that won't bring it back. Fact 93. We don't know why its polarization signature is unique among all known comets, or what material composition would produce such a result. The negative polarization, the way light bounces off the dust in the coma, oriented in a direction that doesn't match any active comet ever observed. It matches trans-Neptunian objects, frozen worlds from the outer edges of solar systems. But those objects aren't active. They don't have comas. They sit in cold orbits, unchanged for billions of years. 3I Atlas is active and shows the polarization signature of an inactive frozen world. That combination doesn't make sense, unless the material was altered by something other than natural processes. Unless the dust particles have a specific structure, a specific composition, designed to scatter light in a particular way. For what purpose? Camouflage? Communication? We don't know. We don't know if it's emitting any radio signals, because no radio observatory has publicly released observations at the frequencies Loeb suggested. Loeb called for radio observations. Point dishes at 3I Atlas. Listen at the hydrogen line at 1420 MHz. See if it's transmitting. See if the wow signal repeats. But no observatory has reported results. Either no one is listening, or they're listening in silence, or they're listening and hearing nothing worth announcing, or they heard something and aren't ready to share. Radio astronomy is careful. False positives are common. Interference from Earth-based transmitters, from satellites, from natural cosmic sources, all create signals that can look artificial until you analyze them carefully. If an observatory detected a signal from 3I Atlas, they'd want to verify it, confirm it, rule out alternatives. That takes time, weeks, maybe months. So the silence might mean nothing, or it might mean we're in the verification phase, where discoveries are checked and rechecked before announcement. We won't know until someone publishes, until a paper appears, until data is shared. Fact 95. We don't know what the Mars orbiters actually photographed because those images remain classified, embargoed, or simply unreleased. The Mars images, the ones that should have answered the size question, the ones captured by HiRISE, by CASIS, by cameras on multiple spacecraft from multiple countries, they exist. The data was collected. But weeks later, it hasn't been released. Technical processing, they say, quality control. But the delay is unusual, and the longer it stretches, the more questions it raises. What's in those images? What did the cameras see? Was it a single solid object or a cluster of fragments? Was there structure, symmetry, anything that looked artificial? We're waiting for answers that should have come already, and the wait itself becomes suspicious. What happens next depends on the calendar, on dates that are approaching fast. On October 29th, 3I Atlas will pass behind the Sun, hidden from all Earth-based observation. If it fragments like a comet, we won't see it. If it deploys probes, we won't see that either. October 29th, perihelion, the closest approach to the Sunday, the moment of maximum heat, maximum stress, maximum activity. For a natural comet, this is when things happen. Outbursts, fragmentation, the nucleus splitting under thermal stress, breaking into pieces that continue along similar trajectories. But we won't see it. The sun's glare blocks everything. The object disappears from view, hidden behind the star it's approaching, invisible for days or weeks. When it re-emerges in late November, we'll see the result. Either it's intact, continuing on its path, or it's fractured, a debris field instead of a single object, or it's accompanied by smaller objects that weren't there before. Fact 97. In late November, it will re-emerge from behind the sun, and telescopes worldwide will have another chance to observe whether it's still intact, still alone. Late November, the re-emergence window. Telescopes will be ready. Observatories worldwide will be watching. Amateur astronomers with backyard setups. Professional instruments on mountaintops. Space telescopes if they can be scheduled. Everyone waiting to see what comes out from behind the Sunday. If 3I Atlas is still there, still intact, still following a purely gravitational trajectory, that's evidence for the comet hypothesis. Natural. Unremarkable. The anomalies were just unusual characteristics. Rare, but not impossible. If it's gone, fragmented into pieces too small to detect, that's also evidence for natural behavior. Comets break up. It happens. But if it's there and changed, if the trajectory shifted, if smaller objects appear in its vicinity, if the orbit is no longer hyperbolic but bound to the sun, then everything changes. Then Loeb's hypothesis moves from speculation to serious consideration. Then we're facing something unprecedented. Fact 98. If Loeb's calculations are correct, any deployed probes could reach Earth orbit between late November and early December 2025, though they'd be too small for current telescopes to detect. Late November through early December, the window when probes released at perihelion could reach Earth using optimal trajectories. Small objects, maybe 10 meters across, maybe smaller, invisible to current detection systems, untrackable, silent. We wouldn't know they were there unless they did something, unless they transmitted, unless they moved in ways that revealed their presence. They could enter orbit around Earth, around the Moon, settle into positions where observation is optimal, and we'd never notice. Our space surveillance network tracks known satellites and debris. It doesn't scan for unknown objects smaller than a certain size. There are gaps in coverage, blind spots. If the probes are quiet, if they're careful, they could be there right now, watching, waiting, reporting back. Or maybe there are no probes. Maybe the whole scenario is speculative fiction, a thought experiment taken too seriously, a hypothesis that will be disproven by simple observation once the data is released. But here's the thing about 3I Atlas. Regardless of what it is, it matters. Fact 99. If 3I Atlas is natural, just an ancient, unusual comet, it's still a scientific treasure. the oldest object humanity has ever studied, potentially predating our sun by billions of years. If it's natural, the scientific value is immense. An object from another star system, material that formed around a different sun, under different conditions, billions of years ago, possibly older than our solar system. A messenger carrying information about planetary formation in other stellar environments, about chemistry and physics under conditions we've never observed directly. The spectra alone are valuable. The carbon dioxide ratio, the polarization signature, the dust composition. Each measurement tells us something about where the object came from, how it formed, what processes shaped it over billions of years in interstellar space. This is comparative planetology on a scale we've never achieved before. Not comparing planets within our solar system, but comparing material from different star systems entirely. Even if every anomaly has a natural explanation, even if the trajectory is just lucky coincidence, even if Loeb is wrong about everything, 3I Atlas is still one of the most important objects we've ever studied. Fact 100. If 3I Atlas is artificial, a probe, a seed ship, a surveyor, or something we don't have words for yet, then October 2025 is the moment everything changed, and we just don't know it yet. And if it's artificial, then nothing is the same. We're not alone. We've never been alone. Someone else is out there, capable of building machines that cross the void between stars, that arrive at other solar systems, that observe and report and possibly act. First contact wouldn't be a radio signal. It wouldn't be a transmission from light years away that we could study and debate and decide how to respond to over the course of years. It would be physical, immediate, here, an object in our solar system, potentially hostile, potentially benign, but definitely real. And the moment everything changed wouldn't be the moment we recognized it. It would be July 1st, when Atlas detected it, or October 3rd, when it passed Mars, or October 29th, when it reaches perihelion. The moment would already have happened, and we'd just be catching up, realizing in retrospect that history pivoted while we were still debating whether it was real. What you believe is up to you. The data is incomplete. The timing is suspicious. The anomalies are real. NASA says comet. Loeb says maybe. The government shut down during the critical observation window. The images remain unreleased. The WOW signal came from the same direction 48 years ago. The trajectory threads through 3 planets, with probability less than 1 in 100,000. The mass is too high, the acceleration is too low, the polarization is unique, and somewhere between Mars and the Sun, an object that traveled for billions of years is making its closest approach to Earth. In December, we'll know more, or we'll have different questions. Either the object will be gone, confirmed as a comet, mystery solved, or the mystery will deepen, or it will end in ways we haven't imagined yet. Picture the night sky tonight. Somewhere up there, beyond the clouds, beyond the atmosphere, 3I Atlas is moving. A speck of light against infinite darkness. 5 kilometers or 20. Ice or metal. Natural or designed. Alone or accompanied. The government says comet. Avi Loeb says maybe. The data says we don't know, and that's what keeps us watching. That's what keeps telescopes pointed at the sky. That's what keeps us asking questions, running calculations, waiting for images that should have been released weeks ago. Because not knowing is uncomfortable. And the stakes, if Loeb is even partially right, are too high to ignore. Whether it's a rock or something more, humanity is watching the sky. And for once, something might be watching back.